Okay, so we have a subwoofer amplifier here that won't power up. It'll pull amps initially, but then it seems like, or it appears to go into some kind of shutdown mode, probably a protection mode of some kind. So we need to open this up, get into here, see what's going on. So what I'm going to do is, if you excuse me and give me just a moment, I'm going to open this tab up here, get it out of its housing. Okay. So now we have our amplifier out of its housing here. And we can take a look at it. We've got our main power board here, which we need to go through. And then we've got our amplifier boards here. We've got a big transformer in here. Big transformer. We've got our primary coils here, and the primary coils here, and then we've got a bunch of secondary taps along this side. That's all inputting into this main power board right here. So it's very possible, and I was told by the customer that this sub stayed on all the time. Now, I'm not going to recommend you don't do that. It just kind of depends on your situation. But now I'm expecting caps in the power supply. That's just kind of what it is. If you decide you want to leave an amplifier on all the time, over time, you'll probably experience some bad caps. So, with that being said, let's make sure that we're getting an input voltage, period. So we'll go ahead and start reading input voltages on the power supply. So first things first, have my multimeter here. And we come in to several different places on this board here. But I'm basically just going to read off of this cap, these caps here. So if I try and read a DC voltage off the cap, you got 3 volts and 111 volts. So 3 volts and 111 volts down on this one underneath here. So just looking at this, trying to get a good grasp and concept of what we have here. Probably just read off. I don't know if you can tell. Maybe I have a better angle here. It looks like no. Underneath all these cables here, down below, is a bridge rectifier. Our initial bridge rectifier. We've got AC coming in. So I'm going to measure actually the AC coming in. Let's power this thing up. Okay, let's power this thing up. And let's start measuring our AC input. (180 volts AC in). Then let's see our DC output from this bridge rectifier. 243 volts DC. Now, this negative voltage here is going to this bottom capacitor here. (120 volts DC, 120 volts DC, 120 volts DC, so very interesting here. It looks like our positive side of the DC is going to come across and into this top cap. Let's see. So, but yep, that makes sense. Yep, that makes sense. So it seems as though we probably have some kind of dual supply here. Now, why does it appear like we're going into a protection mode is the curiosity. When we're getting an input voltage and need to understand how we're outputting. It looks like our main output supply looks like we have some fuses on this subwoofer board here. And what do we have on back? On the subwoofer board here, it looks like we have some fuses. On this board here, let's take a look. Okay, no fuses. Transistors, lots of it looks like amplification chips of some kind. We'll look into those. So we've got what I'll do, starting out just as a basic attempt to fix this, is it looks like this top cable here, which is purple, black, red, black. Red, black is coming from this board here, and purple, black is coming from this board here. If I power this off and I remove those, we'll just eliminate an entire board altogether and see if it still goes into protection mode. It's very possible we're dealing with either bad caps or shorted power transistors, most likely. Just because I've seen this many times now. So let's power this thing back on. We're still going into a protection mode. Let's power it back off. Plug these back in. So that didn't take care of it for us. I unplug this main power bus here. Get the tool out, see if we can get the screwdriver here, pry this up enough. There we go. There we go. Got this pried up and out. Okay. Power this back on. We essentially begin to pull nothing, which would kind of make sense. That's the main power bus bar. Plug this back in. How about this guy? Where are we going with black and green? Black and green appears to be going to this side over here with power transistors down along the bottom here. So if I unplug this, power it back on, we go into a protection mode, lose current. Okay. Where are we going with blue and blue? Blue and blue. Looks like it goes across a diode here. Let's see if I can get y'all a better angle with this camera. for now. You can see blue and blue here going into the side of this board. And if I were to unplug this guy off the main power board here, then we'll turn it on. We go into the same protection mode. Plug it back in. Okay, so at this point, what I need to attempt to understand is, as we turn this on, I'll get back out the multimeter here, and as we turn this on, and I'm probing ground, I need to see voltage outputs on both these capacitors here. So let me power this back on. Okay, so I'll read out voltages here as we go. Here, let me give you a better camera angle about that. Okay, so probing this cap here, minus 120. Well, technically, actually, it would be 120. And then on this cap here, minus 120. So if you take the center of these two caps here are joined together. We read continuity across the center of these two caps. You can hear continuity across. And so we know that we're going to reference that as our ground, and then we're just reading voltage from there. So from the output here, we know we have, it jumps, and basically what I'm doing is this main line here, this main row of wiring in this wire harness, that's going to be our main power lines that I'm trying to read off of. So if I continue probing ground, it looks to me like we're going to go out 120, center, and then out negative 120. So we've got positive 120, negative 120, center, and that actually is coming from purple, black, orange, which you might be able to see purple, black, orange. I get this out of the way here, coming out of a wiring harness from the main power supply board. So if I pull this out, let me make sure that I'm powered off here. Hearing something click. We might need to go investigate that with the power switch. Obviously not the power switch, but with the power switch. Something seems to be not clicking when I turn on, clicking when I turn off. So let's go investigate that. But real quick, let's take purple, black, and orange out of its harness. There we go. Let's power it back on. Same issue, except we're not getting the clicks anymore. So we need to investigate what's going on with these clicks. I was, to be honest, suspecting some kind of relay. But nothing's made itself obvious to me just yet. So, let me put this up. Screwdriver. Okay. Are coming. Let's get our camera back in a good position. What do you feel about that? Yeah, I like that position. Okay, so we are coming out of our wiring harness here, and as I power on and off, it seems to be that this dual 120 supply here of purple, black, orange wire, which we need to trace, it is moving into this board here. Now this purple and black are different. That's coming from up here. So we're looking for purple, we're looking for purple, orange, right? And black is our center negative. So if we could trace down black, we see we have a black exit out into here. That's black. So with that being said, when I power this on, we should see 120 positive, positive come from our purple. So this line here should be positive rail, and what do we enter into? We enter in to, see if I can give us a good view of this here. We come in to a capacitor, a resistor network here, this yellow, or this might be a cap, a fuse. So it's interesting because this fuse appeared to be in good shape to me. Let's test it again. Yep, and we're getting through this fuse. So I'm curious now. If I go back to volts on my meter, and I'm probing here on the cap, or just the negative, are we going to see 120? We are going to see 120 across this fuse. So, if you give me just a moment, we're coming through the fuse. What I need to do next is get a schematic going for this particular unit, so that we can see, now that we know we're on this board, where are we going? Where across this board are we losing our voltage? It seems like we're going in some kind of protective mode. Where is that protection happening? And if I can confirm we're going into protection mode, then we'll start looking at power transistors. It's likely to be a short on the power transistor. But I need to prove that we're going into a protective mode first, and it's not just some kind of missing voltage somewhere. So let me look for a schematic, and I'll be back. Okay. So, update on our amplifier here. So, I have yet to be successful to find it. I discovered that it is likely to be either a Dayton Audio SP500 or some kind of clone of that or copy of that. That's kind of what it seems to me. Like, it doesn't have any branding on the actual unit itself, but it is nearly identical in structure to the SP500, S500, S1000 Dayton Audio. But I can't find any schematics for that at the moment. So here's the next thing I'm going to try. So, power light indication, I like to use that. It's kind of part of my method of discovery. The power light indicator. And the reason I like to use that is because I can trace back that power light indicator back to a source of some kind of power management, and I can find the location of power management in the circuit, right? So here is that light right there. Okay. And so I'm curious if this top board here is going to be doing basically all the power management. We've got 120 coming into here. Now, if it's detecting a short on the subwoofer amplifier board, which is this back board here, then theoretically what we should do, and I'm going to make sure that the amplifier is off, is we could disconnect the cabling in between here and see some kind of more stable amperage as I power this on. So let's get something in here that I can use to pull these tabs out. And you probably can't see what I'm doing. Actually, you definitely can see what I'm doing when I switch to here. This cable here in between. Be very careful to not mess up any tabs, as I'm just kind of working this out of its harness. And there we go, we have it worked out now. Now, good luck getting it back in to me. That's a problem for later me. Sometimes you just create problems for yourself later on, and that's just, you just keep on moving. That's how we do it. So let's power this back on again. Same deal where we have 120 volts passing through here. We take off this wire harness. We've got some kind of protection shutdown mode where it'll pull amps initially, and then shut back off and basically pull very minimal amps, 0.08, and then I can power it off and we'll pull absolutely nothing. So, interesting. Let me go ahead and get this wiring harness back on. My favorite tools of the trade. I use these more than basically any other tool that I have other than my wire snippers. Okay, I can get in here in tight spaces, and I can grab a hold, I can pinch, I can poke, and I can use this pull, push, all kinds of stuff, and we're back in, right? Great tools. Having the right tools is some of the most necessary parts of the job. Okay, so let's try and understand what's happening here. I'm going to try my best to prop up the board here. What I want to do is probe down onto this control board here and see what we have going on. So the very first thing I'm going to do is actually look at these trend. So we've got our main power coming in here. I'm going to look at these transistors. Let's look these up and see what an L7915 is. It actually appears to me to be probably a voltage regulator. L7195. I'm trying to remember what L7195 is. Do I have that right? L7915. My bad. 915 CV. Okay, yes, it's a linear voltage regulator. So we probably have a 7815 over here as well. So I'm looking here. And yep, lo and behold, we have 7915, 7815 here. So we're probably taking in this DC voltage. Let me look up the data sheet here. Look up the pin out for the 7915. So 7915, so that's the negative rail. We've got the input center, output my right. So let's see. Let's probe here. I'm going to try and probe the center here down through the, see if we can get a better angle on this. This thing appears to be getting kind of in our way. Move that harness here. Excellent. Now I'm going to probe down through the center here. Right, and we've got 120. And what are we regulating down to? 106. 100. 106. That doesn't seem right to me here. Let's try probing directly onto the negative pin of this regulator. Okay, that's making more sense now. So we've got minus 20 volts DC coming in, and we're regulating down to a minus 15, which does seem proper. So where are we getting this minus 20 volts DC from is my curiosity now. Well, we've got a couple diodes right here, and it's probably taking this 120 and splitting the supply somehow. So let's get a better camera angle here as I probe into these diodes. 120, 100, 143, 120. So where is minus 20 volts? It's almost as if I need to power this off, try and trace down some voltages here. Or not voltages, some continuity. Okay. So where are we getting this center minus 20 input from? Well, we're getting it from this top, or this bottom diode here. So if I probe this bottom diode again, sorry, the top diode here at the surface here. So where is this ground coming from? Is this ground coming in anywhere? Yes. So we've got this ground connected all the way over to here in our main cap here. So then why am I, when I'm probing voltage, seeing 100 volts DC here, but seeing minus 20 here? I mean, it should be the same ground, and I'm probing the same exact center point. 100 volts DC, minus 20 volts DC, minus 15 volts. Well, let's take a look at the 7815. See what we're working with. We are working with a little bit of a different configuration. We're working with the center being ground, the input being over to my right, and the output being over to my left. Okay, so let's measure center to output. And we have a positive 15 volts. Okay, so positive 15 minus 15 rail that came in on this board here. Excellent deal so far. Let's figure out what we're gonna do next. What I'm gonna actually do is take a look at this transistor here, which appears to be another possibly regulator L7. It's got some stuff on it. Hold on, L7815. So we've got another 7815 7915 combination here. So let's take a look at this voltage regulator and see if we've got the same kind of voltage experience across these transistors here. So if we're looking at the 7915, which I believe is what this side is, this is 78. So that would mean that I probably need to flip this around. Just a moment. Okay, if I have this flipped around, I can honestly kind of perch it up here. So what we're looking at here is this power transistor and this power transistor, and I'm going to probe them from the back here. See what we have going on. So this was our 7815 over here on this side. 7815 has a center, ground, and we're going to output 15 volts when we input 18. And then the other one we're going to output minus 15 volts. Here. Okay, voltages seem regular across these power transistors here. I mean these voltage regulating transistors here. So we're kind of rolling out options here. This is going to be turn into quite the interesting one to discover what's going on. Power this off for a moment. So we know we have each board. Let's recap what we know so far. Each board has its set of voltage regulators coming in. 15 positive, negative railing, and both these boards have a good positive 15, negative 15 supply in them. Now I'm seeing one more heat sinked transistor down here that we need to look at, see what's going on there. Just examining the board, seeing what else we might get down to power transistors and see if those are shorted. I could see exactly what kind of protective circuitry this board has and go from there if I could find schematics. I'll keep looking. I've been unsuccessful so far, but we're making some headway. We're learning things. We know we have good power out from our main power supply. It's still likely we're going into some kind of protection mode somewhere. I don't know. I might have better luck just trying to find a short rather than trying to find a short in the likely places, rather than try and understand how this protection circuitry is working. If I had a schematic, that would obviously be easy compared to what we're doing now, but that's fine. Might look up some of these chips here, and I can do that real quick before we go. TLO, so this is TL074, just a basic op-amp package. I'm sure that we have a good supply on that. Looks like we've got some more op-amp packages. At least on this board, I don't see any thing that stands out as, oh, that's going to be some kind of power supply management IC. On this board here, nothing jumps out at me too much. Got a bunch of 4580D 4026 chips here. Very interesting. Very interesting. So, yeah, I would say that that's our next steps. Might go try and find more information on this thing online, as well as probably come back and try and probe around for some shorts in the most likely places, power transistors. We can measure our rail, in other places and go from there. Okay, till next time.